1.2 functions and graphs. So in some respects, I would say the first 4 questions in this section are probably the hardest thing in this whole section, just because it's a little bit different than how we would have done stuff in the past. But they basically want you to write a formula for the function and then use that formula to find the value that they're trying to solve for. So it's kind of like a short little word problem, and that's what we're dealing with. So the height h of an equilateral triangle as a function of its side length s the height of an equilateral triangle. I'm just going to put EQ triangle because I don't want to write the whole thing out again. Of side length 3. So it's a little confusing, but basically we're writing the formula for an equilateral triangle to find the height as a function of the side length, and then we're ultimately going to solve for the height when the side length is 3. So obviously equilateral triangle, well, that is not, well, it's close enough. What do you know about the angles of an equilateral triangle?
They're all the same.
Yeah, they're all the same, so they would all be 60 degrees. So I'm just going to write it in one of them. But so then we're looking at the height of it, which is this going straight down here. This would be our h. So if this is splitting this in half, that means that this angle here has to be 30 degrees. Yep. And then we've got our sides here. Now, do you happen to know the formula for an equilateral triangle? Yeah, I figured probably not. That's not a common one. Even if you learned it in geometry, you don't use it very much, and it's not something that we do really anything else with. But basically the height is equal to root 3 over 2 times s. Now, without knowing that, we can see it because we can look at the side here. We can know about special triangles. So the special triangle would be a 30, 60, 90 triangle. And so basically they are 1, 2, and root 3 are the side lengths there. So then looking at them as a ratio basically of that is how we would be finding it. So they want us to find the height then with side length 3. So all we need to do is plug in 3 for, I guess technically they said it's in meters, but I forgot to write that. So they want us to find the height given that the side length is 3. So all we're literally doing is plugging in 3. So h is equal to the square root of 3 over 2 times 3, or 3 root 3 over 2. And the units are meters. And so that's all that they're looking for with these ones. So nothing super crazy. This one is just a little bit more different. Number 4 is a little bit easier than that one because it's a shape that we're more familiar with. So number 4 is volume. So we're dealing with the volume of a sphere. As a function of the radius r, and then we're going to find the volume when the r is equal to 3 centimeters. Do you know the formula for volume of a sphere?
Yeah.
So just as a heads up, you will need to know the volume of a sphere, volume of a cone, volume of a cylinder for the AP exam. Obviously, that's quite a ways away, but It's okay. I forget them often too, but the volume of a sphere is 4/3 pi r cubed. So basically, that's our function. And all we need to do now is plug it in. So v equals 4/3 pi times 3 cubed. And what was that, 27 divided by 3 is 9 times 4 is 36, so 36 pi. And I guess we should say centimeters cubed. But there's what the volume would be. So they're not really like hard, they're just kind of like, I guess annoying is a good way to put them.
So what happens to the 3? Like it's 4/3 pi, and then it's like a 3 cubed.
I just reduced it because 3 cubed is 27, and then I divided it by 3.
Oh, okay.
I just did it all like in one step basically. But obviously if you want to write it out, you can do that too. What's next? Identify the domain and range, sketch the graph of the function. So these are just going to be like kind of quick graphs. They're not going to be like, super spot on. We're just getting like an approximate. So number 6 is y equals x squared minus 9. So what do you know about this shape? Or what graph is this going to produce? If you don't remember the name, you can, if you like know what it looks like, you can.
It's like the V.
The U, yeah.
Yeah.
Yep. So this is a parabola. So we would have I did this too far. Basically like this. This is a parabola. Because this would be considered outside the parentheses, this is going to shift it down 9 units. So basically down here. And like that's why I was saying like we don't have to be like super precise with this one. I'm not worried about it. We're just getting a rough graph of what this looks like. And then they want us to state the domain and range of this graph. So the domain of any parabola would be all real numbers because it's spanning the whole thing. You're going to notice probably if you check your answers in the book that they're going to write it as negative infinity to infinity. Either way is fine. It really doesn't matter. And then the range is obviously the y values that it takes on. So if we're looking at basically from down here and it's going up. So this would be from -9 included all the way up to infinity. Or I can write, negative infinity, -9 to infinity. And then that would be our range for that one. Let's see. 8. Y equals negative square root of negative x. Do you remember what a square root function looks like on a graph?
That's the V. Like the. I thought it was.
That one's absolute values of v. So a square root function generically would look like this. It's where it like starts and it keeps going up. However, this one is basically double reflected. So it's flipped backwards and down. So I guess to you it's this way. So essentially this graph is actually going to be down here. This would be the graph. This would be the square root of x. This is minus the square root of minus x down here. And as you're doing these, if you don't remember what they look like, 1, you can plot points, or 2, you can just type it in your calculator. It really doesn't matter for the sake of this. So then the domain and range, what would the domain be of the blue line?
it start at 0?
Yeah, so 0 would be included.
Alright, so like 0 to negative infinity.
Yeah, well, flip it, but yes. So that it's in numeric order. Yep, negative infinity to 0, and we're including 0. What about the range?
I guess just like the same thing.
Yeah, because it'll go on forever as well. Let's see. Let's look at 12 really quick. So 12 is y equals 1 plus 1 over x squared. So this is not a graph that I just know what it looks like off the top of my head. I know it's going to have some asymptotes because it's a fraction and I have an x on the bottom. So vertical asymptotes is when the denominator is 0. So basically the only place that that's going to occur is if x is 0. So I know that I have a vertical asymptote at x equals 0. Always good to check to see if we have a horizontal asymptote along with it, because that may give us more information about our graph as well. So a horizontal asymptote is where we're looking at Bobo, Bosco, and Botno. So this one is bigger on bottom, so that would be Bobo, so y equals 0. I throw my pen. So I know I have those two asymptotes. Aside from that, I know nothing about what this graph is going to look like. I could maybe make a wild guess and get close, but probably not, because it's, like I said, just not something we deal with all the time. So what I would suggest is when you set this up to do it is that you go ahead and put your asymptotes on here with the dotted lines so that you know where it can't cross, essentially. And then I would probably say just try to plot a couple points on here and just see what it looks like. Main reason I'm saying this way is because obviously if it was on a no calculator question on the exam, that's where it would be an issue. So we know we can't have anything at 0, so I don't even need to check that, but I could check at +1. So at +1, I would have 1 plus 1. So that would be at 2. So I would have a point at 1, 2. At 2, I would have a point at 1.5. At 3, I would have a point at 1 1/3. So I'd be coming down a little bit. So I could probably safely assume it's going to look something kind of like this. I just realized those numbers are being squared, so it's actually like 1 1/4 and 1 1/9, but it's close enough. It's fine. And then going the other direction, put in -1. Well, that's also going to be up at 2. And then basically it's that right there. Once I do that, that tells me it's going to look the same on the left as it does on the right, just inverted. So I basically can just put points in line with them over here and then draw them up like that. So basically that's what that graph would look like. So as far as when we do our domain, it's going to basically keep getting really, really close to 0, but we won't ever touch it. So this is where we'll do the negative infinity to 0, not including union 0 to infinity. And range is basically going to be the same way, except for we don't have any part of our graph on the bottom, so we're just going to have the one thing. So this one would be from 0, not including, to infinity, like that. Oh wait, actually. So actually, I just realized I said that wrong. So technically speaking, even though we have the asymptote at 0, this graph has been shifted up because of this +1. So this actually should be 1 right here. I was like looking at the answer in the book and I was like, wait a minute. So a lot of times it is wherever our asymptote occurs, but in this case it's shifted up. So if it was just like 1 plus x squared, then it would be 0 too, but because of the +1 there. I always forget that. And basically I kind of plugged in like a really big number. Well, I say a really big number, like 10. So 1 plus 1 over 10 squared or 1 over 100. I was like, okay, so basically you're just going to keep getting closer and closer to 1, but never actually hitting it. All right, jumping a little bit. Determine whether the function is even, odd, or neither. It says try to answer without writing anything, but I don't really like that. I like checking them to see like why they are what they are, instead of just guessing. Obviously there are some that you can just look at and tell, but then there's some that you might think are going to be one thing and then they end up being something else. So I like to actually check them. So 22, y equals x plus x squared. Do you remember how to check if a function's even or odd?
It's like sort of there.
Yeah. So it's basically we do f of negative x, like if we were treating it as a function. So we're going to put a negative x in for everything. If the sign stays the same, then it is even. And if it changes sign, like the whole thing changes sign, then it's odd. And if it's like a split, then it's the neither option. So we'll do negative x plus negative x squared. So this would give us negative x plus x squared. So one of the signs stayed the same and one was different, so this one would be neither. Then 26, y equals x plus x cubed. So if we do the same thing with this one, we would have negative x plus negative x cubed. That would give us negative x minus x cubed. And the reason, basically what you're ultimately trying to show, if you remember, is that f of negative x is equal to negative f of x, to show that it's odd, or that f of negative x is equal to f of x to show that it's even, essentially is what we're trying to do. So in this case, we could, if we were so inclined, to take out that negative and have it as x plus x cubed to show that it's the whole thing has been changed to match. So this one would be odd. I think these ones are like not as bad. I think the pre-cal book ones are like a little bit confusing sometimes in like how they did them. Some of the stuff that book does, I wouldn't mind having a new textbook, but I don't want to rewrite everything that I have, so. Let's see, 30. I think this is our last thing, make sure. Y equals 1 over x squared minus 1. So 1 over negative x squared minus 1 would be 1 over x squared minus 1, which is the exact same thing we started with. So this one would be even. Make sure I'm not missing anything important here. Oh, we're good. All right, so then basically 1 through 29, every other odd. I don't know that it actually ends on 29. It may end on 27, but whatever it goes through as good there.